The threshold of sleep, where consciousness dissolves. Welcome. Pause for a moment. Close your eyes and breathe deeply. Have you ever wondered what happens in that mysterious space between wakefulness and sleep? That liminal zone where your thoughts begin to drift, where the solid world around you gradually loses its grip on your awareness. Tonight, we embark on a journey into one of nature's most profound mysteries, the realm of dreams, where the language of science meets the poetry of the human soul. Before we begin, subscribe to the Relaxing Science channel, give this video a like, and share your location and the time below. We would love to know where you are listening from and what moment of your day you are sharing with us. The threshold of sleep is not an abrupt doorway, but rather a gentle slope. Your body does not simply switch off like a light. Instead, it descends gradually through layers of consciousness, each one softer and more permeable than the last. As you lie in the darkness, your muscles begin to release their tension. The grip of the waking world loosens. Your breathing deepens naturally without effort. This is the beginning of a transformation that will reshape your entire being for the next several hours. When you first close your eyes, your mind is still active, still engaged with the day's concerns. Thoughts flutter through your awareness like birds landing on branches. Some linger, others pass quickly. This is the stage called the hypnagogic state, a word derived from ancient Greek meaning leading to sleep. During this phase, your brain waves begin to change their rhythm. The alert, fast oscillations of wakefulness gradually slow and become more organized. Your heart rate decreases. Your body temperature drops slightly. These are not random changes, but rather a carefully orchestrated symphony conducted by ancient neural mechanisms that have protected and restored humans for millions of years. What makes this threshold so fascinating is that it exists in a realm where neither science nor poetry alone can fully capture its essence. A neuroscientist might tell you that your brain is transitioning from beta waves to alpha waves, that your prefrontal cortex is beginning to disengage from executive control, that your neurotransmitter levels are shifting in precise ways. All of this is true, measurable and verifiable, yet simultaneously, a poet might describe this same moment as the soul's gradual release from the demands of the day, as a return to the primordial waters from which consciousness emerges, as a nightly death and rebirth that renews our capacity to live. Both descriptions are accurate because they are describing the same phenomenon through different lenses. Science provides us with the mechanism, the how of sleep's onset. Poetry provides us with the meaning, the why and what for. Together, they create a complete picture of something that is simultaneously a biological process and a spiritual experience. During this threshold period, your senses do not simply shut down, rather they become reorganized. Your awareness of external sounds, lights, and sensations does not disappear, but instead becomes less urgent, less demanding of your attention. You might hear a distant sound, perhaps the wind outside your window, or the gentle hum of a refrigerator, but instead of jolting you to alertness as it would during the day, it now becomes part of the fabric of your experience, incorporated into the very dreams that are beginning to form at the edges of your consciousness. The biological mechanisms at work during this transition involve a delicate balance of neurotransmitters and hormonal shifts. Your brain begins to produce more melatonin, a hormone that signals to your body that darkness has fallen and sleep should commence. Simultaneously, the levels of orexin, a neurotransmitter that promotes wakefulness, begin to decline. This is not a sudden drop, but rather a gentle decrease, like the dimming of a light controlled by a rheostat rather than a switch. Your body's internal clock, located in a region called the suprachiasmatic nucleus, coordinates this entire process based on the darkness around you and the time of day. As you sink deeper into this threshold, something remarkable happens. Your mind begins to generate spontaneous imagery. You might see colors, shapes, or fleeting scenes that seem to come from nowhere. These hypnagogic hallucinations are perfectly normal and are often described as one of the most creative moments of the day. Artists and musicians have long captured these images, recognizing them as a source of inspiration. The boundary between imagination and perception becomes blurred here, and your brain seems to be warming up for the more elaborate dream narratives that will follow. The muscles of your body respond to this descent into sleep as well. You might experience a sudden jerk or spasm called a hypnic jerk, a remnant perhaps of our evolutionary past, when such movements may have served to check whether we were safe before fully surrendering to sleep. These involuntary movements are so common that nearly everyone experiences them at some point, yet most people never give them conscious thought. Your jaw may relax, your shoulders may drop, your hands may unclench. Your body is systematically releasing its held tensions, preparing itself for the restorative work that sleep will accomplish. This threshold period typically lasts between 5 and 20 minutes, though it can vary considerably from person to person and from night to night depending on stress levels, sleep debt, and individual physiology. Some people transition quickly and easily, while others may hover in this liminal space for longer periods, their minds still somewhat engaged with the concerns of the day. Understanding that this is a natural process rather than something to be fought or rushed can actually help ease the transition. The paradox of sleep is that trying too hard to fall asleep often prevents it from happening. Acceptance and patience are among the most effective tools for crossing this threshold smoothly. The threshold of sleep represents a kind of trust. You are releasing your conscious control, allowing your body to take over the intricate work of rest and restoration. You are surrendering to a process that is far more intelligent and sophisticated than your conscious mind could ever orchestrate. In a very real sense, you are allowing yourself to be held by the ancient wisdom of your own biology, carried along by currents of neurochemistry that have been refined through countless generations of human evolution. This nightly surrender is both a small death and a profound act of faith in the continuity of your own existence. The architecture of night, how your brain rewires while you rest. As you move deeper into sleep, your brain embarks on an architectural project of stunning complexity. The structure of a night's sleep is not uniform or monotonous, but rather follows a carefully orchestrated pattern of distinct stages, each with its own purpose and its own unique neural signature. Understanding this architecture reveals why sleep is far more than simple rest. It is a dynamic process of rebuilding, reorganizing, and revitalizing every aspect of your cognitive function. The night unfolds in cycles, each lasting approximately 90 minutes. Within each cycle, your brain moves through different stages, progressing from lighter sleep into deeper sleep, and then into a period of intense dreaming. This cyclical pattern repeats 4 to 6 times throughout a typical night, creating a rhythm as fundamental to human biology as the beating of your heart or the cycles of day and night themselves. When you first enter sleep, you move into what is called Stage 1 non-REM sleep. This is the lightest stage of sleep, a transitional zone that is still somewhat close to wakefulness. Your brain waves continue to slow, and your body temperature continues to drop. During this stage, you are still somewhat aware of your surroundings. A loud noise or a significant change in temperature might still wake you. Your muscles begin to relax more completely, though involuntary movements may still occur. This stage typically lasts only a few minutes before you progress deeper. Stage 2. Non-REM sleep is where you spend a substantial portion of your night, roughly half of your total sleep time. During this stage, your brain enters a state of what might be called conscious rest. Your awareness of the outside world diminishes further. Your body becomes less responsive to external stimuli. Your brain waves continue their gradual slowing, but now they are interrupted by brief bursts of activity called sleep spindles, rapid oscillations of neural firing that appear to be involved in memory consolidation and the integration of new information. Your heart rate slows, your breathing becomes more regular, and your muscles continue their progressive relaxation. What is particularly fascinating about Stage 2 sleep is that it is during this time that a great deal of memory processing occurs. Your brain is not simply resting, it is actively engaged in the work of taking the experiences and information from your waking day and beginning the process of integrating them into your long-term memory. This is why adequate sleep is so crucial for learning. Without sufficient Stage 2 sleep, new information remains fragile and unstable, vulnerable to being forgotten. With proper sleep, those memories become consolidated, strengthened, and woven into the fabric of your existing knowledge. As your sleep deepens, you progress into stage 3 non-REM sleep, also called deep sleep or slow-wave sleep. This is the most restorative stage of sleep, the time when your brain is least responsive to external stimuli. Your brain waves now show the characteristic pattern that gives this stage its name: slow, deep oscillations that occur at a frequency of less than 2 cycles per second. These slow waves are among the most distinctive and important brain patterns in the entire sleep cycle. During this stage, your body's restorative processes are in full operation. Growth hormone is released in significant quantities. Your immune system strengthens. Cellular repair processes accelerate. Metabolic waste products are cleared from your brain through a process called the glymphatic system. The glymphatic system is a recent discovery in neuroscience, and it represents one of the most important findings about why sleep is essential for health. During deep sleep, the spaces between your brain cells actually expand, allowing cerebrospinal fluid to flow more freely through your brain tissue. This fluid carries away metabolic waste products that have accumulated during your waking hours, including proteins associated with Alzheimer's disease and other neurological conditions. In essence, your brain is cleansing itself during deep sleep, removing the accumulated debris of consciousness and thought. Without adequate deep sleep, these waste products accumulate, contributing to cognitive decline and neurological damage. Deep sleep is also the stage during which your body does much of its physical repair work. If you have exercised during the day, if you have experienced any physical stress or minor injuries, it is during deep sleep that your body marshals its resources to repair and strengthen tissues. Athletes and those engaged in physically demanding work require more deep sleep for this reason. Your immune system also does critical work during deep sleep, producing and releasing cytokines that help fight infection and inflammation. This is why people who are sleep deprived tend to get sick more frequently and recover more slowly from illness. After you have spent sufficient time in deep sleep, typically about 30 to 40 minutes in the first cycle, though this can vary, your brain begins to transition towards something entirely different. Your brain waves begin to accelerate. Your muscles become temporarily paralyzed. Your eyes begin to move rapidly beneath your closed eyelids. You have entered the stage called REM sleep, which stands for rapid eye movement sleep. This is the stage most closely associated with vivid narrative dreams, and it represents a dramatic shift in how your brain is functioning. During REM sleep, your brain is actually more active than it is during wakefulness. Your prefrontal cortex, the region responsible for logical thinking and rational analysis, shows decreased activity. Meanwhile, your limbic system, the ancient part of your brain responsible for emotions and instincts, becomes highly activated. Your visual cortex fires intensely, generating the rich imagery of dreams. Your brain is creating a complete alternate reality, populating it with characters, scenarios, and narratives that feel absolutely real to you while you're experiencing them. The first REM period of the night is typically quite short, lasting only about 10 minutes. But as the night progresses and you cycle through successive 90-minute cycles, the REM periods become progressively longer. By the time you reach your final REM period in the early morning hours, you might be dreaming for 30 to 40 minutes, or even longer. This is why the dreams you remember most vividly are often those that occur in the hour or two before you wake up. They are simply the longest and most intense REM periods of the night. The architecture of sleep is not random, but rather follows a blueprint that appears to be optimized for different types of learning and memory consolidation. Early in the night, when your deep sleep periods are longest, your brain is focused on physical restoration and the consolidation of procedural memories, the skills and motor patterns you have learned. As the night progresses and REM sleep becomes more dominant, your brain shifts its focus toward the consolidation of emotional memories and the integration of complex information. Your brain is literally rebuilding itself each night, incorporating the day's experiences into its existing structure and preparing itself for the challenges of the coming day. This nightly architecture is remarkably consistent across all humans, suggesting that it reflects something fundamental about how our brains have evolved to function. Yet within this consistent pattern, there is significant individual variation. Some people naturally spend more time in deep sleep, while others spend proportionally more time in REM sleep. Some people cycle through these stages quickly, while others progress more slowly. These individual differences reflect variations in genetics, age, and personal physiology. What remains constant is that the brain requires all of these stages, and disruption to any of them can have significant consequences for health and function. The chemistry of dreams, neurotransmitters as invisible architects. Beneath the visible architecture of sleep stages lies an invisible chemical landscape. Your dreams are not simply products of neural activity, but are fundamentally shaped by a symphony of neurotransmitters and neurochemicals that orchestrate every aspect of brain function during sleep. These molecules are the invisible architects of your inner world, the chemical messengers that determine what you will experience, how you will feel, and what your mind will create during the night. Neurotransmitters are small molecules that carry signals between nerve cells in your brain. They are the fundamental currency of neural communication, the means by which one neuron influences another. During waking hours, your brain maintains a carefully balanced mix of different neurotransmitters, each playing a specific role in maintaining consciousness, focus, and emotional regulation. But as you enter sleep, this chemical balance shifts dramatically. Some neurotransmitters diminish while others increase, creating an entirely different neurochemical environment. One of the most important shifts involves a neurotransmitter called norepinephrine. During waking hours, norepinephrine is abundant in your brain, and it is crucial for maintaining alertness, focus, and vigilance. It keeps your attention directed outward toward the world around you. It heightens your sensitivity to potential threats and opportunities. It supports the kind of logical, linear thinking that characterizes waking consciousness. But as you fall asleep, norepinephrine levels plummet. By the time you enter REM sleep, norepinephrine is almost completely absent from your brain. This absence of norepinephrine is one of the key factors that allows dreams to unfold in their characteristic way, illogical, emotional, and unconstrained by the demands of external reality. Another crucial neurotransmitter is serotonin, which is involved in mood regulation, emotional stability, and the perception of time. During waking hours, serotonin helps maintain a sense of continuity and order. It contributes to feelings of well-being and emotional resilience. But during REM sleep, serotonin levels also decline significantly. This reduction in serotonin, combined with the absence of norepinephrine, creates a neurochemical environment in which the normal constraints on thought and perception are loosened. Without these neurotransmitters to maintain order and logical coherence, your brain is freed to generate the bizarre, emotionally intense, and often illogical narratives that characterize dreams. Meanwhile, as these neurotransmitters decline, another set of chemical messengers becomes increasingly active. Acetylcholine is a neurotransmitter that is particularly abundant during REM sleep. It is involved in attention, memory, and the integration of sensory information. During REM sleep, acetylcholine levels are as high as they are during waking hours. But because the other neurotransmitters that normally modulate and organize thought are absent, acetylcholine's effects are radically different. Instead of helping you attend to external reality, it is now engaged in generating the vivid internal imagery of dreams. The story becomes even more complex when we consider the role of the neurotransmitter dopamine. Dopamine is involved in motivation, reward, and emotional significance. During dreams, dopamine activity is altered in specific ways that make dream content feel emotionally charged and meaningful. This is why dreams often feel so emotionally intense and why they can linger in your memory long after waking. The emotional weight of a dream is not arbitrary, but is directly shaped by dopamine activity in your brain during REM sleep. Beneath the level of individual neurotransmitters, there is an even deeper chemistry at work. Your brain produces endogenous opioids during sleep, chemicals that are structurally similar to morphine and that act on the same receptors. These endogenous opioids may contribute to the sense of comfort and safety that deep sleep provides. They may also play a role in pain modulation, which is why adequate sleep is so important for managing chronic pain conditions. Your brain is, in a very real sense, producing its own medicine during sleep, crafting a neurochemical environment that supports healing and restoration. The pineal gland, a small endocrine structure deep within your brain, produces melatonin in response to darkness. Melatonin is not a neurotransmitter in the classical sense, but rather a hormone that circulates through your bloodstream and affects virtually every cell in your body. It signals to your entire being that it is time to sleep. But melatonin does far more than simply induce drowsiness. It is a powerful antioxidant that protects your cells from damage. It regulates your body's temperature and metabolism. It influences your immune function. It even appears to play a role in regulating the content and intensity of dreams, though the precise mechanisms are still being researched. The chemistry of sleep also involves the regulation of ions, charged particles like sodium, potassium, and calcium that move in and out of your cells. These ion gradients are essential for neural function, and they shift in specific ways during sleep. The movement of calcium into neurons during sleep, for instance, appears to be involved in the process of synaptic plasticity, the ability of synapses to strengthen or weaken in response to experience. Sleep is when your brain does much of the work of pruning away weak synaptic connections and strengthening important ones, and this work depends on careful regulation of calcium and other ions. Another crucial chemical is gamma-aminobutyric acid, or GABA, which is the primary inhibitory neurotransmitter in your brain. GABA acts like a brake on neural activity, preventing neurons from firing excessively. During deep sleep, GABA activity is particularly important in helping to quiet the constant chatter of waking consciousness, allowing your brain to rest from the relentless work of maintaining awareness. Yet during REM sleep, GABA activity is reduced in certain brain regions while remaining high in others, creating a complex pattern of inhibition and excitation that allows the creative generation of dream content. Glutamate is the primary excitatory neurotransmitter in your brain, the chemical messenger that makes neurons fire. During waking hours, glutamate activity is carefully balanced with GABA activity to maintain appropriate levels of neural function. But during sleep, this balance shifts. The ratio of excitation to inhibition changes in ways that are specific to each sleep stage. This shifting balance is not a bug in the system, but rather a feature. It is the means by which your brain shifts between different modes of operation, from the focused, directed consciousness of wakefulness to the fluid, creative consciousness of dreams. The chemistry of sleep and dreams is not a static condition, but a dynamic process that evolves throughout the night. As you progress through successive sleep cycles, the neurochemical environment changes in subtle but important ways. Early sleep cycles are characterized by higher levels of some neurotransmitters and lower levels of others, creating conditions that favor deep sleep and physical restoration. Later sleep cycles show different chemical signatures, creating conditions that favor more REM sleep and more vivid dreaming. This progression across the night is not random, but appears to be optimized for different types of learning and memory consolidation. Understanding the chemistry of dreams reveals something profound about the nature of consciousness itself. Your waking consciousness is not the default state of your brain, but rather one specific configuration among many possible configurations. That configuration depends on a particular neurochemical environment maintained by specific levels of various neurotransmitters and hormones. Change that chemical environment, and you change consciousness itself. This is why dreams feel so different from waking thought, not because you are experiencing something supernatural or mystical, but because the fundamental neurochemical conditions of your brain have changed. Yet this scientific understanding does not diminish the wonder of dreams. If anything, it deepens it, revealing that your brain is capable of generating multiple forms of consciousness, each with its own validity and purpose. Rapid eye movement, the gateway to the dream realm. The eyes have long held a special place in human consciousness. We speak of them as windows to the soul, as mirrors of emotion and intention. Yet during sleep, your eyes become something far more remarkable. They become the gateway to an entirely different realm of consciousness. The rapid, jerky movements of your eyes during REM sleep are not incidental to dreaming, but are deeply intertwined with the very mechanism of dream generation. Understanding REM sleep and the phenomenon of rapid eye movement opens a doorway into understanding how your brain creates its most vivid and emotionally intense experiences. REM sleep was first discovered in the 1950s by researchers who noticed that sleepers' eyes moved rapidly beneath their closed eyelids during certain phases of sleep. This observation was quickly connected with the phenomenon of dreaming. When people were awakened during periods of rapid eye movement, they reported vivid narrative dreams far more often than when they were awakened during other stages of sleep. This correlation between eye movement and dreaming was so consistent and striking that it seemed to suggest a causal relationship. Perhaps, researchers speculated, the eyes were following the action in the dream, much as your eyes would follow a bird flying across your field of vision during waking hours. The actual relationship between eye movements and dreaming is more complex and more fascinating than this simple explanation. During a typical REM period, your eyes move in patterns that are far too rapid and erratic to be simply following dream action. The movements occur in bursts, with your eyes darting back and forth, up and down, and in complex patterns that seem to follow no particular logic. Yet these movements are not random. They show consistent patterns that vary depending on the content of the dream and the individual dreamer. Some researchers have found that the direction and pattern of eye movements during a dream can sometimes predict the spatial layout of the dream environment, or the direction in which the dreamer is moving within the dream. What makes REM sleep unique and different from all other states of consciousness is not simply the eye movements, but rather the entire constellation of neural and physiological changes that occur during this stage. Your brain waves during REM sleep show a pattern that is remarkably similar to waking brain waves: fast, desynchronized activity that suggests high levels of neural processing. Yet your body is profoundly different from the waking state. Your muscles are paralyzed, your temperature regulation is impaired, your ability to respond to external stimuli is dramatically reduced. You are essentially locked into a state in which your brain is highly active and generating vivid internal experiences while your body is completely incapacitated. The paralysis that occurs during REM sleep is called REM-atonia, and it is produced by a specific neural mechanism. A region in your brainstem called the locus coeruleus normally generates norepinephrine, which keeps your muscles toned and ready for action. But during REM sleep, the locus coeruleus becomes nearly silent. Simultaneously, another region called the sublaterodorsal tegmental nucleus becomes active and releases a neurotransmitter called glycine, which actively inhibits the motor neurons that control your muscles. The result is that you are essentially paralyzed from the neck down during REM sleep, unable to move your voluntary muscles even though your brain is intensely active and you are experiencing vivid sensations of movement. This paralysis serves an important protective function. If you were able to move freely during REM sleep while experiencing vivid dreams, you would act out your dreams. You might swing your arms, kick your legs, or even run around your bedroom, responding to the perceived threats and opportunities within your dream world. This would be dangerous for you and for anyone sleeping nearby. The paralysis of REM sleep ensures that your dream experiences remain purely internal, safely contained within your mind without affecting your body's physical location in the world. Yet the paralysis of REM sleep is not absolute. Small movements do occur during REM sleep. Your eyes move rapidly, as we have discussed. Your facial muscles may twitch, your fingers or toes may move slightly, your breathing may become irregular. These small movements are not prevented by the REM-atonia, but rather occur despite it. The paralysis is selective, affecting primarily the larger voluntary muscles, while allowing some movement of the eyes and face. In rare cases, when the normal mechanisms that produce REM-atonia malfunction, people experience a condition called REM sleep behavior disorder, in which they do act out their dreams, sometimes with violent or dangerous movements. This condition provides dramatic evidence of how important the paralysis of REM sleep is for safety and well-being. The gateway to the REM realm involves not only eye movement and muscle paralysis, but also a profound shift in how your brain processes information. During REM sleep, your visual cortex is highly active, generating the rich imagery of dreams. Your parietal cortex, which is involved in spatial awareness and navigation, is also active, contributing to the sense of moving through space and interacting with objects and people in the dream world. Your temporal cortex, involved in memory and emotional processing, shows significant activation. But crucially, your prefrontal cortex, the region most involved in logical thinking, self-awareness, and reality testing, shows markedly reduced activity during REM sleep. This shift in cortical activity explains many of the characteristic features of dreams. Without the critical oversight of your prefrontal cortex, your dreams can be illogical and bizarre. You can be in two places at once, or a person can change identity mid-dream without you noticing. The laws of physics do not apply. Impossible things happen and you accept them without question. Your sense of self can be unstable. You might see yourself from outside your body, or you might be someone else entirely. All of these phenomena are possible because the brain regions that normally maintain logical consistency and reality testing are offline during REM sleep. The gateway to the dream realm is also characterized by a shift in neurochemical conditions that we discussed in the previous section. The reduction of norepinephrine and serotonin, combined with elevated levels of acetylcholine and altered dopamine activity, creates a neurochemical environment in which your brain operates according to different rules than those that govern waking consciousness. This is not a malfunction or a problem, but rather a sophisticated adaptation that allows your brain to operate in a different mode, one optimized for different kinds of mental work. One of the most intriguing aspects of REM sleep is the question of consciousness itself. Are you conscious during REM sleep? In some sense, clearly you are. You are experiencing vivid sensations, emotions, and narratives. You are aware of your dream world and responding to events within it. Yet in other senses, you are not conscious as you are during waking hours. You lack awareness of your actual body and your actual surroundings. You lack the kind of reflective self-awareness that characterizes waking consciousness. You are unable to critically evaluate the reality of your experiences. You are not aware that you are dreaming, in most cases, even though you are having subjective experiences. This question of consciousness during REM sleep has profound implications for how we understand the nature of consciousness itself. It suggests that consciousness is not a unitary phenomenon, but rather a collection of capacities and functions that can be present or absent in different combinations. During REM sleep, you have consciousness of internal sensations and narratives, but you lack consciousness of external reality and critical self-awareness. During waking hours, you have consciousness of both external and internal phenomena, along with the capacity for critical reflection. Different brain states create different forms of consciousness, each with its own characteristics and capabilities. The gateway to the dream realm through REM sleep is thus far more than simply a matter of your eyes moving back and forth. It is a comprehensive transformation of how your brain operates, involving shifts in neural activity patterns, neurochemical conditions, muscle tone, sensory processing, and the very nature of consciousness itself. Understanding REM sleep and the phenomenon of rapid eye movement opens a window into one of the most remarkable capabilities of the human brain, the ability to generate entirely convincing alternate realities, complete with their own logic, their own emotional resonance, and their own meaning. Symbolism and the unconscious. What your dreams are trying to tell you. Since ancient times, humans have understood that dreams carry meaning. The ancient Egyptians, Greeks, and Romans developed elaborate systems of dream interpretation. Indigenous cultures around the world have traditions of dream analysis and dream work. In the 19th and 20th centuries, pioneers of psychology like Sigmund Freud and Carl Jung elevated dream interpretation to a central place in their understanding of the human psyche. Yet modern neuroscience has revealed that the question of what dreams mean is far more complex than any of these traditions fully recognized. Your dreams are not simply messages from your unconscious mind, nor are they merely the random firing of neurons during REM sleep. They are something far more subtle and more interesting. They are the visible surface of processes occurring deep within your mind. The symbolic nature of dreams has long fascinated both artists and scientists. So a dream in which you are falling might represent anxiety about losing control in your waking life. A dream of being chased might reflect a fear you are avoiding. A dream of water might symbolize emotions or the unconscious mind itself. A dream of flying might represent freedom or transcendence. Yet the question of why dreams take these symbolic forms, and whether the symbols have universal meanings or are highly personal, remains a subject of debate and investigation. Freud believed that dreams were the royal road to the unconscious mind, that they revealed hidden desires and repressed conflicts that could not be expressed directly in waking consciousness. He developed an elaborate system of dream interpretation in which nearly every symbol had a fixed meaning. A snake might represent a father figure or a phallic symbol. A house might represent the self or the psyche. Water might represent the unconscious. Yet modern research has suggested that Freud's approach, while psychologically insightful, may have been too rigid and too focused on sexual and aggressive themes. Carl Jung, a student of Freud who later diverged significantly from his teacher's theories, proposed a different understanding of dreams. Jung believed that dreams were not primarily about repressed desires, but rather about bringing unconscious material into consciousness in order to achieve psychological integration and wholeness. He emphasized the importance of personal associations to dream symbols rather than universal interpretations. A snake in one person's dream might have very different significance than a snake in another person's dream, depending on that person's individual experiences and associations with snakes. Jung also introduced the concept of the collective unconscious, a layer of the unconscious mind that is shared by all humans and that contains universal symbols and archetypes that appear in the myths, art, and dreams of all cultures. Modern neuroscience has provided new insights into how and why dreams generate symbolic content. Research suggests that the symbolic nature of dreams emerges from the particular configuration of neural activity during REM sleep. Because your prefrontal cortex is relatively quiet during REM sleep, the normal processes of logical analysis and critical evaluation are not operating. Meanwhile, your limbic system, the ancient part of your brain responsible for emotions, is highly active. Your visual cortex is generating rich imagery. Your temporal lobe, involved in memory, is active. The combination of these neural processes creates conditions in which your brain generates narratives and images that are emotionally charged and that draw on memories and associations from throughout your life. The symbols in your dreams are not planted there by some mysterious unconscious intelligence trying to send you messages. Rather, they emerge naturally from the particular way your brain is processing information during REM sleep. When your brain activates a memory or an emotional association, it does not activate it in isolation, but rather activates the entire web of related memories, emotions, and associations connected to it. A memory of a person might activate memories of places you were with that person, emotions you felt with that person, objects associated with that person, and countless other related memories. When your brain is generating a dream narrative, it draws on these activated networks of associations, weaving them together into a coherent story. This process of drawing on networks of associations explains why dreams often have a symbolic or metaphorical quality. If you are anxious about a difficult conversation you need to have with someone, your brain might not generate a straightforward dream about that conversation. Instead, it might generate a dream about being chased, or about drowning, or about being trapped in a confined space. These dream images are not arbitrary symbols chosen by some unconscious intelligence to represent your anxiety. Rather, they are natural products of your brain's associative networks. Anxiety activates memories and images associated with threat and danger. Your brain weaves these threat-related associations into a narrative, which becomes your dream. The personal nature of dream symbolism becomes clear when you consider how differently the same dream image might be interpreted by different people. A dream of a snake might evoke fear in someone who has had a frightening encounter with a snake, curiosity in someone who has studied snakes professionally, or spiritual significance in someone from a culture that reveres snakes. The symbol does not have a fixed meaning, but rather its meaning emerges from the particular network of associations and experiences that the dreamer brings to it. Yet there is evidence that some dream symbols do have more universal meanings across cultures. Dreams of water, for instance, appear in the dreams and mythologies of virtually every culture. often associated with emotions, the unconscious or transformation. Dreams of falling appear across cultures and are commonly associated with anxiety or loss of control. Dreams of flying appear across cultures and are often associated with freedom or transcendence. This universality might reflect the fact that all humans share certain fundamental experiences: the experience of being in water, of falling, of moving through space. It might also reflect the fact that certain emotional states and psychological processes are universal to human experience, and dreams naturally generate symbols that represent these universal experiences and processes. The relationship between dreams and the unconscious mind is more complex than early psychologists understood. Your unconscious mind is not a separate entity with its own desires and agendas, locked away and trying to communicate with your conscious mind through the disguised language of dreams. Rather, the unconscious is better understood as all the mental processes that occur outside of conscious awareness. Your brain is constantly processing information, making associations, activating memories, and generating emotions and responses, most of which occur below the threshold of conscious awareness. Dreams do reveal something about these unconscious processes, but they reveal them not as hidden messages, but as the natural output of how your brain processes information when it is in the particular neurochemical and neural state of REM sleep. What your dreams are trying to tell you then is not messages from a mysterious unconscious intelligence, but rather information about how your brain is processing the concerns, emotions, memories, and associations that are active in your mind. If you are having recurring dreams about being unprepared for an exam, this is not a message from your unconscious that you are secretly incompetent. Rather, it is a reflection of the fact that concerns about performance and preparation are active in your mind, and your brain is exploring these concerns through the medium of dream narrative. Understanding this can actually be more helpful than interpreting the dream as a symbolic message, because it directs your attention to the actual underlying concern that your brain is processing. The practice of working with dreams, paying attention to them, reflecting on them, exploring their content and imagery, can be valuable not because dreams contain hidden messages that need to be decoded, but because this practice can help you understand what your brain is concerned with, what emotional themes are active in your mind, and what associations and connections your brain is making. By paying attention to your dreams, you are essentially listening in on your own mental processes, gaining insight into how your mind is working and what it is working on. Memory consolidation: how dreams transform experience into wisdom. Every day, your brain encounters an overwhelming amount of information. Thousands of sights, sounds, smells, tastes, and tactile sensations. Countless conversations and interactions, new facts and concepts, problems to solve, emotions to process. If all of this information remained in your conscious awareness, your mind would be utterly overwhelmed. Instead, most of this information is filtered out, forgotten, or relegated to the background. But some of it is important. Some of it needs to be remembered, integrated into your existing knowledge, and made available for future use. This is where sleep, and particularly the process of memory consolidation that occurs during sleep, becomes crucial. Memory consolidation is the process by which memories are transformed from a fragile, temporary state into a more stable, long-lasting form. Without sleep and memory consolidation, you would be unable to learn anything. You would wake each morning with no memory of the previous day. Every skill you have ever learned would be lost. Every relationship you have ever had would be forgotten. Every piece of knowledge you have acquired would vanish. Sleep makes learning possible, and memory consolidation is the mechanism by which this occurs. The process of memory consolidation involves complex interactions between different brain regions and different types of neurochemical activity. When you experience something new during your waking hours, when you learn a new fact, practice a new skill, or have an emotionally significant experience, that experience creates new patterns of neural activity in your brain. Synapses, the connections between neurons, are strengthened or weakened based on this activity. These changes in synaptic strength are the physical basis of memory. But these newly formed memories are fragile. The synaptic changes are not yet stable, and without consolidation, these memories would be lost relatively quickly. During sleep, particularly during the different sleep stages, the memories that were formed during the day are replayed and processed in different ways. During stage 2 non-REM sleep, your brain engages in a process of systems consolidation in which memories that were initially stored in the hippocampus, a brain structure crucial for forming new memories, are gradually transferred to the cortex, where they become part of your long-term knowledge base. This process involves the reactivation of patterns of neural activity that were present during the original learning, but in a more abstract and generalized form. Your brain is essentially extracting the essential features of what you learned and integrating it into your broader knowledge. During deep sleep, your brain engages in further memory processing. The slow waves that characterize deep sleep appear to be involved in strengthening important memories and weakening less important ones. Your brain is, in a sense, editing the memories from your day, keeping what is important and letting go of what is not. This editing process is crucial for learning. Not everything you encounter is worth remembering, and your brain needs to be able to distinguish between what is important and what is trivial. The process of memory consolidation during deep sleep accomplishes this, allowing your brain to extract signal from noise and to integrate new information into your existing knowledge in a way that is coherent and useful. During REM sleep, a different type of memory consolidation occurs. REM sleep appears to be particularly important for the consolidation of emotional memories and for the integration of new information with existing knowledge. During REM sleep, your brain is not simply replaying memories as they occurred, but is creatively recombining elements from different memories, making new associations and connections. This is where dreams come in. The dreams you experience during REM sleep are, in a sense, your brain's way of working through the integration of new information and experiences. Your brain is taking elements from your day, from your memories, from your concerns and preoccupations, and weaving them together into narratives that explore different possible connections and associations. This understanding of dreams as part of the memory consolidation process suggests that dreams have a deeply functional purpose. They are not merely random neural noise or a byproduct of REM sleep, but rather an active and important part of how your brain integrates new information and transforms experience into wisdom. When you dream about a problem you're trying to solve, your brain is not simply entertaining you with a fantasy. Rather, it is actively working on the problem, exploring different associations and connections, trying out different combinations of ideas and approaches. Research has shown that sleep and dreams are particularly important for certain types of learning. Learning a new motor skill, learning to play an instrument, learning a new sport, learning to type, requires sleep for consolidation. Students who get adequate sleep after studying perform better on exams than students who do not sleep. Athletes who get adequate sleep improve faster and perform better than those who are sleep deprived. People learning a new language benefit significantly from sleep. In all of these cases, the consolidation that occurs during sleep, and particularly the memory processing that occurs during REM sleep and dreaming, is essential for turning practice and experience into lasting learning. The relationship between dreams and learning is not always obvious. You might have a dream that seems completely unrelated to anything you are trying to learn. Yet that dream might actually be involved in consolidating a memory or working through a problem. Your brain is not necessarily dreaming directly about what you are trying to learn. Rather, your brain is exploring the associations and connections related to what you are learning, and these explorations manifest themselves in the form of dreams that might seem tangential or irrelevant to the conscious mind. There is also evidence that REM sleep and dreaming are particularly important for what is called insight learning, the sudden understanding or solution to a problem that seems to come out of nowhere. You might go to sleep puzzled by a problem, unable to see a solution, and wake up with the answer suddenly clear. This phenomenon, which has been experienced by scientists, artists, and problem solvers throughout history, is not magic, but rather the result of memory consolidation and associative processing that occurs during REM sleep. Your brain, freed from the constraints of conscious logic and working with the associative networks activated during REM sleep, can make novel connections and see solutions that were not apparent during waking consciousness. The transformation of experience into wisdom, then, is not something that occurs purely through conscious reflection and logical thinking. Rather, it requires the work of sleep and dreaming. Your brain needs time and the particular neurochemical and neural conditions of sleep to process experiences, to extract their essential features, to integrate them with existing knowledge, and to generate new insights and understanding. This is why sleep is not a luxury or a waste of time, but rather an essential component of learning and growth. Without adequate sleep, without the memory consolidation that occurs during sleep, and without the creative dream work that occurs during REM sleep, you cannot fully learn from your experiences or develop the wisdom that comes from integrating experience into a coherent understanding of yourself and the world. The emotional laboratory. Why dreams feel so real and vivid? Close your eyes for a moment and recall a vivid dream you have had. Perhaps it was a dream in which you were experiencing intense fear, being chased by something threatening, falling through space, or facing some terrible danger. Or perhaps it was a dream of intense joy or wonder, of flying through the air or meeting someone you love. The remarkable thing about such dreams is not simply that you experience these sensations and emotions while dreaming, but that they felt absolutely real. Your heart was pounding, your muscles were tense, your emotions were genuine and intense, yet you were lying safely in your bed, and there was no actual threat or joy-inducing event occurring. Your brain had created an entirely convincing, alternate reality, complete with emotions that felt authentic and compelling. This phenomenon, the vividness and emotional intensity of dreams, has fascinated psychologists and neuroscientists for decades. How is it possible that your brain can create experiences that feel completely real, that engage your emotions fully and completely, when there is no actual external stimulus to justify those emotions? The answer lies in understanding how emotions are generated in your brain and how the particular neural and neurochemical conditions of REM sleep create an emotional laboratory in which your brain can explore and process emotions with unprecedented intensity and freedom. Emotions are not simple unitary phenomena, but rather complex states involving multiple brain systems working in concert. When you experience an emotion, several things happen simultaneously. Your amygdala, an almond-shaped structure deep in your brain, becomes activated. The amygdala is the emotional evaluator of your brain, the part that quickly assesses whether something is threatening, rewarding, or emotionally significant. When your amygdala detects a threat, either a real external threat or an internal representation of a threat, it activates your sympathetic nervous system, triggering what is commonly called the fight or flight response. Your heart rate increases, your breathing quickens, your muscles tense, and your body floods with stress hormones like adrenaline and cortisol. But emotions also involve your prefrontal cortex, the region of your brain most involved in conscious thought and decision-making. Your prefrontal cortex can modulate and regulate emotional responses. It can tell you that something that feels threatening is actually safe, or that something that feels rewarding might not be in your best interest. The prefrontal cortex provides context and perspective to emotional experiences, allowing you to respond to emotions thoughtfully rather than reactively. During REM sleep and dreaming, this normal balance between emotional activation and emotional regulation is dramatically altered. Your amygdala is highly active during REM sleep, generating emotional responses and emotional salience. But your prefrontal cortex shows markedly reduced activity during REM sleep. This means that the emotional activation generated by your amygdala is not being modulated or regulated by the prefrontal cortex. The emotional responses generated during dreams are not being evaluated for their accuracy or appropriateness. They are simply being experienced fully and completely, without the normal conscious oversight and regulation that would occur during waking hours. This explains why dream emotions can be so intense and so unconstrained. During a nightmare, you might experience terror as intense as any fear you have felt in your waking life. Your heart pounds, your muscles tense, your breathing quickens. Yet when you wake up, you immediately recognize that there was no actual danger, and your fear dissipates. This happens because your prefrontal cortex, now fully active, can evaluate the situation and recognize that you are safe. But during the dream itself, without the moderating influence of your prefrontal cortex, the fear feels completely real and completely justified. The emotional laboratory of dreams serves important functions. One of these functions is the processing and regulation of emotions. During your waking life, you encounter many emotionally significant events. You have conversations that make you angry. You encounter situations that make you anxious. You experience losses and disappointments. You have moments of joy and triumph. These emotional experiences create changes in your brain, activating emotional networks and generating emotional memories. During REM sleep, your brain revisits these emotional experiences, exploring them in the safe environment of dreams. Your amygdala becomes activated, and you re-experience the emotions, but because you are in the protected environment of sleep, you can experience them without the constraints that would apply during waking hours. This process of emotional re-experiencing and processing during dreams appears to be important for emotional regulation and emotional healing. Research has shown that people who do not get adequate REM sleep have difficulty regulating their emotions. They are more irritable, more anxious, more prone to mood disturbances. Conversely, adequate REM sleep and the emotional processing that occurs during dreams appears to help people manage their emotions more effectively during waking hours. In a sense, your dreams are a kind of emotional gymnasium, a place where your brain can exercise emotional capacities and processes in a safe environment. The vividity and emotional intensity of dreams also serves the function of making emotional memories more memorable. Emotionally significant experiences are remembered better than neutral experiences. This is an adaptive feature of human memory. Important events, especially those with emotional significance, need to be remembered so that you can learn from them and avoid repeating mistakes. The emotional intensity of dreams appears to enhance the consolidation of emotional memories. When you have a vivid, emotionally intense dream, that dream is more likely to be remembered and more likely to influence your waking behavior and emotional responses. There is also evidence that the emotional laboratory of dreams serves a function in exploring possible emotional responses to hypothetical situations. Your brain can activate scenarios that might never actually occur and can explore your emotional responses to those scenarios. If you dream about being humiliated in public, your brain is exploring your emotional response to this possibility. If you dream about being reunited with someone you love, your brain is exploring the emotions associated with this possibility. These explorations, occurring in the safe environment of sleep, may help prepare you emotionally for real-world situations. They may help you develop emotional flexibility and resilience. The question of why dreams feel so real despite the fact that they are internal experiences is closely related to the question of how the brain generates any sense of reality at all. The sense that something is real is not generated by the external world directly, but rather by your brain's evaluation of the information it is receiving. Your brain generates a sense of reality when it is receiving consistent, coherent information from multiple sensory systems, and when that information is consistent with your expectations and your understanding of how the world works. During dreams, your brain is generating sensory information internally: visual imagery, auditory information, tactile sensations, and presenting this information to the same parts of your brain that would process external sensory information during waking hours. Because the sensory information is being generated internally, and because your brain's reality testing mechanisms are offline during REM sleep, your brain accepts this internally generated information as real. You do not question it. You do not wonder whether you are dreaming. You simply accept the dream world as real, just as you accept the waking world as real during waking hours. This is not a failure of your brain, but rather a reflection of how the brain generates the sense of reality. The sense of reality is not a fixed property of the world, but rather an interpretation that your brain generates based on the information available to it and the neural state it is in. Recurring patterns. The soul's persistent messages. Throughout human history, people have noticed patterns in their dreams. Certain themes return again and again. Certain nightmares recur with disturbing frequency. Certain symbols and scenarios appear night after night, sometimes for weeks or months, sometimes for years. These recurring patterns in dreams have often been interpreted as messages from the soul, as the psyche's way of insisting on attention to something important. And while the language of the soul speaking through dreams might be poetic rather than scientific, modern neuroscience suggests that there is something very real and very important happening when dreams become repetitive and persistent. Recurring dreams typically emerge when there is something unresolved in your life. You might be facing a problem that you have not yet solved. You might be dealing with anxiety about a situation that remains uncertain or threatening. You might be processing a loss or a disappointment. You might be grappling with a conflict in a relationship. The particular content of the recurring dream often reflects in some way the underlying concern or unresolved issue. A person who is anxious about job security might have recurring dreams about losing their job or being unable to perform their work. A person who is grieving might have recurring dreams of the person they have lost. A person who is in conflict with someone might have recurring dreams of confrontation with that person. The mechanism underlying recurring dreams involves the activation of particular emotional and conceptual networks in your brain. When you are preoccupied with a concern or problem, that concern activates a network of related thoughts, emotions, and memories. During REM sleep, when your brain is exploring associations and making connections, this activated network becomes the source material for dreams. If the concern is not resolved, the network remains activated, and similar dreams recur. Each time you have the recurring dream, your brain is essentially revisiting the concern, exploring it from different angles, trying to work through it. This process of recurring dreams working through unresolved issues can be valuable and productive. The dreams are your brain's way of continuing to work on a problem, even while you are asleep. Each iteration of the dream, each new variation on the theme, represents your brain exploring different aspects of the issue or trying out different possible resolutions. Over time, as you consciously work on resolving the underlying issue, the recurring dreams typically diminish or disappear. This is not because the dreams have delivered their message and are no longer needed, but rather because the underlying concern has been resolved or has become less emotionally charged, and therefore the network of associated thoughts and emotions is no longer being strongly activated. Recurring nightmares are a particularly intense form of recurring dreams, and they often reflect significant emotional distress or unresolved trauma. People who have experienced trauma often have recurring nightmares that replay the traumatic event or variations on it. These nightmares are not a sign of weakness or pathology, but rather a reflection of how the brain processes traumatic experiences. Trauma creates intense emotional memories and activates emotional networks powerfully. During REM sleep, these networks become active and nightmares result. The nightmares, while distressing, appear to be part of the brain's attempt to process and integrate the traumatic experience. There is evidence that working with recurring nightmares through techniques like imagery rehearsal therapy, in which people consciously imagine and practice modified versions of the nightmare while awake, can help reduce the frequency and intensity of the nightmares. This suggests that recurring nightmares are not fixed and unchangeable, but rather reflect patterns of neural activation that can be modified. By consciously engaging with the nightmare content and rehearsing different outcomes, people can change the patterns of activation in their brain, and the nightmares diminish. Certain recurring dream themes appear to be nearly universal across human cultures and across history. These include dreams of being chased, dreams of falling, dreams of being unprepared for an exam or a performance, dreams of losing teeth, dreams of being naked in public, and dreams of being unable to move or speak. The universality of these dream themes suggests that they reflect something fundamental about human psychology and human concerns. Being chased might reflect the universal human experience of threat and danger. Falling might reflect the universal fear of loss of control. Being unprepared might reflect anxiety about performance and competence. These universal themes appear in the dreams of people across cultures and across historical periods, suggesting that they reflect deep aspects of human experience that are not culturally specific. Yet within these universal themes, there is significant individual variation. The specific context of a dream of being chased, what is chasing you, where you are being chased, what happens at the end, varies considerably from person to person and from dream to dream. This suggests that while the broad themes might be universal, the specific content of dreams reflects individual concerns, experiences, and preoccupations. Your brain is not simply generating dreams from some universal template, but rather is drawing on your own particular memories, concerns, and emotional networks to create unique variations on universal themes. One of the most interesting aspects of recurring dreams is that they often change over time. A recurring nightmare might gradually become less intense or less frequent as you process the underlying issue. A recurring dream might shift its content subtly, reflecting changes in how you are thinking about or processing the underlying concern. These changes in recurring dreams can actually be quite informative. They can tell you something about how you are progressing in dealing with the underlying issue. If a recurring nightmare about being chased gradually becomes less intense, or if the dream begins to end differently with you escaping or confronting the pursuer, this might reflect progress in how you are processing the underlying threat or concern. There are also practices that can help you work with recurring dreams more consciously. Keeping a dream journal, writing down your dreams as soon as you wake up, can help you remember your dreams more clearly and can help you notice patterns over time. Reflecting on the emotional content of recurring dreams and what they might reflect about your current concerns can help you understand what your brain is working on. Some people find it helpful to consciously engage with recurring dreams through guided imagery or creative writing, exploring alternative versions of the dream or imagining different outcomes. These practices are not about interpreting dreams as having hidden symbolic meanings, but rather about consciously engaging with the process that your brain is already engaged in, the process of working through concerns and unresolved issues through the medium of dreams. Lucidity and awareness, becoming conscious within the dream. One of the most fascinating phenomena in the realm of dreams is the experience of lucid dreaming, becoming aware that you are dreaming while the dream is still ongoing. In a lucid dream, you retain your sense of self-awareness and your capacity for conscious thought and decision-making, while simultaneously being immersed in a convincing dream environment. You might realize that you are dreaming and then deliberately choose what to do within the dream. You might decide to fly, or to explore a particular location, or to confront a threatening figure. You maintain awareness of the dream as a dream, yet you are still experiencing vivid sensations and emotions. This state of consciousness represents something quite remarkable, a hybrid state that combines features of both dreaming and waking consciousness. Lucid dreaming is not a rare or abnormal phenomenon. Research suggests that many people experience lucid dreams at least occasionally, though the frequency varies considerably from person to person. Some people experience lucid dreams several times a week, while others might experience them only rarely or never. There appear to be individual differences in the capacity for lucid dreaming, possibly related to differences in brain structure and function. People who are naturally more reflective and analytical in their waking consciousness tend to experience lucid dreams more frequently. People who practice techniques for inducing lucidity tend to experience lucid dreams more frequently. The neural basis of lucid dreaming is an area of active research, and it is revealing something quite interesting about the nature of consciousness. During a lucid dream, your brain shows a pattern of neural activity that is somewhat different from both ordinary REM sleep and waking consciousness. Your prefrontal cortex, which is relatively quiet during ordinary REM sleep, shows increased activity during lucid dreams. This makes sense. To be aware that you are dreaming, you need to have some capacity for reality testing and reflection, capacities that depend on prefrontal function. Yet your brain also shows many of the characteristics of REM sleep. Your brain waves show patterns similar to those of ordinary dreams. The paralysis of REM sleep still occurs, preventing you from moving your body. Your visual cortex and other sensory processing regions are still active, generating the dream imagery. In essence, lucid dreaming represents a state in which your brain has reactivated some of the capacities of waking consciousness, particularly the capacity for reflection and reality testing, while remaining in the state of REM sleep. This partial reactivation of waking consciousness within the dream state creates a unique form of consciousness that is neither fully like waking nor fully like ordinary dreaming. This hybrid state is possible because consciousness is not a simple on-off phenomenon, but rather involves multiple capacities and functions that can be present or absent in different combinations. The experience of lucid dreaming raises fascinating questions about the nature of choice and agency. In a lucid dream, you experience yourself as making choices, deciding what to do within the dream, directing your attention toward particular aspects of the dream environment, deliberately exploring the dream world. Yet your choices within the dream are still products of your brain's activity. Your brain is still generating the dream environment, still generating the sensations and experiences, still creating the impression of choice and agency. Does this mean that your sense of choice is illusory? Or does it suggest something deeper about how choice and agency work? This question is not unique to lucid dreaming. Even in your waking life, your sense of choice and agency emerges from your brain's activity. Your brain generates the sense that you are choosing freely, even though that sense of choice is itself a product of neural processes. The difference in lucid dreaming is simply that the processes generating the dream environment and your sense of choice are more obviously and transparently products of your own mind. You are not receiving input from an external world that constrains and shapes your choices. You are simply exploring the possibilities generated by your own brain. People who practice lucid dreaming often report that it can be a source of creativity, problem-solving, and personal growth. In a lucid dream, you can deliberately explore scenarios and possibilities that might not be available in waking life. You can practice confronting fears in a safe environment. You can explore creative ideas and artistic possibilities. You can experiment with different approaches to problems. Some artists, musicians, and scientists have used lucid dreaming as a tool for creative work. The freedom of the lucid dream environment, combined with the access to your brain's associative and creative capacities, can generate novel ideas and insights. There is also evidence that lucid dreaming can be therapeutic for people with recurring nightmares. Because lucid dreaming allows you to maintain awareness and agency within the dream, you can consciously change the narrative of the nightmare. Instead of being passively terrified by a nightmare, you can become lucid, recognize that you are dreaming, and deliberately change the course of the dream. You might confront a threatening figure, knowing that it is only a dream. You might choose to wake up. You might deliberately transform the nightmare into something less threatening. With practice, people can use lucid dreaming to reduce the frequency and intensity of nightmares and to reclaim a sense of agency and control in relation to their dream life. The techniques for inducing lucid dreaming are varied. Some involve practices during waking hours, such as regularly questioning whether you are dreaming and looking for inconsistencies in your environment that would indicate you are dreaming. These practices, repeated regularly, can eventually carry over into dreams, and you might find yourself questioning whether you are dreaming while actually in a dream. Some techniques involve setting intentions before sleep, explicitly telling yourself that you intend to become lucid in your dreams. Some techniques involve timing your sleep in particular ways to maximize the amount of REM sleep you get in the early morning hours, when REM periods are longest and most likely to produce lucid dreams. The experience of lucid dreaming reveals that the boundary between sleeping and waking consciousness is not as sharp and absolute as we might assume. Your brain is capable of generating multiple different states of consciousness, each with its own characteristics and capacities. Lucid dreaming represents a state in which features of both dreaming and waking consciousness are present. This flexibility in consciousness, this capacity to shift between different states and to blend features of different states, is one of the remarkable capabilities of the human brain. The practice of lucid dreaming also offers a kind of laboratory for studying consciousness, because lucid dreaming allows you to observe your own consciousness in a relatively stable state. It provides an opportunity to study how consciousness works. Lucid dreamers can report on their experiences in a way that ordinary dreamers cannot, because they maintain reflective awareness throughout the experience. Researchers have used lucid dreamers as subjects in studies of consciousness, asking them to signal when they become lucid, to perform particular mental tasks within the dream, and to report on their subjective experiences. These studies are revealing new insights into how consciousness works and how the brain generates the sense of self and agency. The healing power of night visions, dreams as medicine for the mind. In traditional and indigenous cultures around the world, Dreams have long been understood as having healing power. Dream quests, vision quests and dreamwork practices have been central to healing traditions in many cultures. While modern Western medicine largely dismissed dreams as having no medical significance, contemporary neuroscience is revealing that these ancient traditions were recognizing something real and important. Dreams do indeed have healing power, though not in the magical or supernatural sense, but rather through the neurobiological mechanisms of how dreams affect the brain and the body. The healing power of dreams operates through multiple mechanisms. One of the most important is the processing and regulation of emotions. As we discussed earlier, dreams provide an emotional laboratory in which your brain can explore and process emotional experiences. This emotional processing is crucial for emotional healing. When you experience a loss or a disappointment or a trauma, that experience creates emotional memories and activates emotional networks in your brain. If these emotional experiences are not processed and integrated, they can continue to cause emotional distress and can interfere with your functioning. Dreams, through their emotional intensity and their capacity to explore emotional content, facilitate the processing and integration of emotional experiences. Research has shown that people who have adequate REM sleep recover more quickly from emotional stresses than people who are sleep deprived. People who have experienced trauma and who get adequate REM sleep show better recovery and lower rates of post-traumatic stress disorder than trauma survivors who are sleep deprived. The emotional processing that occurs during dreams appears to be protective against the development of emotional disorders. Conversely, disruption of REM sleep can impair emotional recovery and can increase vulnerability to emotional and psychiatric problems. Dreams also have healing power through their role in memory consolidation and in the integration of experience into wisdom. When you experience something difficult or challenging, sleep and dreams help you integrate that experience into your broader understanding of yourself and the world. You do not simply forget the difficult experience or suppress it, but rather you process it, extract whatever lessons or insights it offers, and integrate it into your existing knowledge and understanding. This integration is what transforms difficult experiences into sources of growth and wisdom, rather than sources of ongoing distress. There is also evidence that dreams can facilitate physical healing. Sleep in general is important for physical healing and recovery, and REM sleep and dreams appear to play a particular role. People who have experienced physical trauma or illness and who get adequate sleep, including adequate REM sleep, recover more quickly than those who are sleep deprived. The reasons for this are not entirely clear, but they likely involve the role of sleep in reducing inflammation, enhancing immune function, and facilitating the consolidation of procedural memories related to physical recovery. One of the most intriguing aspects of the healing power of dreams is the phenomenon of spontaneous insight or problem solving that occurs through dreams. People have long reported that problems that seemed intractable while awake suddenly become solvable after sleep. Scientists, artists, and innovators throughout history have reported having dreams in which solutions to problems became apparent or in which creative breakthroughs occurred. This phenomenon is not simply a matter of having time to rest and think. Rather, there appears to be something about the particular way your brain processes information during REM sleep and dreaming that facilitates insight and problem solving. During REM sleep, your brain is making associative connections in ways that do not occur during waking consciousness. Your prefrontal cortex, which normally constrains and directs thought in particular directions, is less active. Your associative networks are more loosely connected and more prone to making novel associations. This creates conditions in which your brain can see connections and possibilities that were not apparent during waking consciousness. When you wake up and reflect on the dream, you might suddenly see a solution to a problem that had seemed unsolvable, or you might see a creative possibility that had not occurred to you before. The healing power of dreams also extends to what might be called spiritual or existential healing. Many people report that dreams have helped them gain perspective on their lives, to understand themselves better, or to feel connected to something larger than themselves. While this kind of healing is harder to measure scientifically than physical or emotional healing, it is no less real or important. Dreams can facilitate what might be called existential processing, the working through of questions about meaning, purpose, identity, and connection. Through dreams, your brain can explore these existential dimensions of human experience, and this exploration can contribute to a sense of wholeness and integration. Traditional healing practices that involve working with dreams, such as dream interpretation, dream work, and vision quests, appear to be facilitating the natural healing processes that occur during sleep and dreaming. By bringing conscious attention to dreams, by reflecting on them and working with them, people can potentially enhance the healing benefits of dreams. This is not because dreams contain mystical messages that need to be decoded, but rather because conscious engagement with dreams can help you understand what your brain is working on and can help you consciously participate in the healing and integrating work that your brain is doing. The recognition that dreams have healing power has important implications for understanding sleep disorders and for the treatment of psychological and physical illness. Sleep disorders, which disrupt normal sleep and dreaming, can have significant negative effects on health and well-being. Insomnia, sleep apnea, and other sleep disorders that disrupt REM sleep can impair emotional regulation, cognitive function, and physical healing. Conversely, the promotion of healthy sleep and the protection of REM sleep is an important health intervention. For people dealing with trauma, emotional distress, or physical illness, ensuring adequate sleep and adequate REM sleep is not a luxury, but rather an essential component of healing. The poetry of sleep science, where numbers meet meaning. We have now traveled through the landscape of sleep and dreams, exploring the mechanisms and processes through which your brain creates the experience of sleep and dreaming. We have examined the architecture of the night, the chemistry of dreams, the nature of consciousness during REM sleep, the symbolism that emerges in dreams, the role of dreams in memory consolidation and emotional processing, the phenomenon of lucid dreaming, and the healing power of dreams. Throughout this journey, we have been moving between two languages, the language of science and the language of poetry. And now, as we approach the end of our exploration, it is time to reflect on how these two languages relate to each other and what emerges when we allow them to speak together. Science speaks in the language of mechanism and process. It describes the precise neural correlates of sleep and dreaming. It measures brain waves and neurotransmitter levels. It traces the flow of information through neural circuits and the patterns of activation across brain regions. It quantifies the duration of different sleep stages and the frequency of eye movements during REM sleep. Science asks how things work and provides detailed mechanistic answers to those questions. This is enormously valuable. Through science, we understand that sleep is not a passive state, but an active process of restoration and rebuilding. We understand that dreams are not random neural noise, but are products of specific patterns of neural activity. We understand that sleep and dreams are essential for learning, memory, emotional regulation, and physical health. Yet science, by its very nature, leaves certain questions unanswered. Science can tell you what happens in your brain during sleep, but it cannot tell you what sleep means. Science can measure the neural correlates of emotion during a dream, but it cannot capture the subjective quality of the emotional experience. Science can demonstrate that sleep is essential for health, but it cannot explain why the experience of sleep and dreams feels so deeply significant, so meaningful, so connected to the core of what it means to be human. Poetry speaks in the language of meaning and experience. It describes sleep as a nightly death and rebirth, as a return to the primordial waters from which consciousness emerges, as a surrender to forces larger than ourselves. It speaks of dreams as the soul's exploration of its own depths, as messages from the unconscious, as visions that reveal hidden truths. Poetry does not ask how things work, but rather what they mean and what they reveal about the human condition. Through poetry, we recognize that sleep is not simply a biological process, but a profound spiritual experience. We recognize that dreams are not simply neural phenomena, but are expressions of the deepest dimensions of the human soul. Yet poetry, by its very nature, is not constrained by the requirements of accuracy and verification that govern science. A poetic description of sleep and dreams can be beautiful and meaningful without being literally true. Poetry can express truths that are real and important, even though they are not scientifically verifiable. The remarkable truth is that science and poetry are not in conflict, but are rather two different ways of approaching and describing the same reality. A scientific description of the glymphatic system, clearing metabolic waste from the brain during sleep, is accurate and important. A poetic description of sleep as a cleansing of the soul is also expressing something true and important, even though it is not literally accurate in a scientific sense. The scientific truth is that sleep is a period during which your brain removes accumulated metabolic waste products. The poetic truth is that sleep provides a kind of renewal and restoration that feels like a cleansing of the soul. These are not contradictory truths, but rather complementary truths expressed in different languages. Similarly, a scientific description of memory consolidation during sleep, the reactivation and reorganization of neural patterns that were formed during the day, is accurate and important. A poetic description of sleep as the time when experience is transformed into wisdom is also expressing something true and important. The scientific truth is that sleep facilitates the integration of new information into your long-term memory. The poetic truth is that sleep enables growth and learning, the transformation of raw experience into understanding. Again, these are not contradictory but complementary truths. When we allow science and poetry to speak together, when we allow the precision of scientific description to complement the depth and meaning conveyed through poetic language, we arrive at a more complete understanding of sleep and dreams. We understand not only how sleep works, but also why it matters. We understand not only the mechanisms through which dreams are generated, but also the significance of dreams in the human experience. The equation of science and metaphor, the meeting point where numbers and meaning converge, is found in the recognition that consciousness itself is the fundamental mystery that both science and poetry are attempting to address. Science approaches consciousness by studying brain activity, neural correlates, and neurochemical processes. Poetry approaches consciousness by exploring subjective experience, meaning, and the human condition. Neither approach alone is sufficient. Science without poetry becomes sterile and disconnected from the lived experience of being human. Poetry without science becomes untethered from reality and from the actual mechanisms through which human experience is generated. In the context of sleep and dreams, this integration of science and poetry reveals something profound. Sleep and dreams are not merely biological processes that we tolerate in order to maintain health and function, though they are certainly that. Sleep and dreams are also expressions of something fundamental about consciousness and about the human condition. They are the nightly reminder that consciousness is not a fixed state, but a fluid and dynamic phenomenon that can shift and transform. They are the nightly invitation to surrender to processes and forces that are larger than our conscious minds, to trust in the intelligence of our bodies and our brains. They are the nightly opportunity to explore our depths, to process our experiences, to transform them into wisdom and meaning. The poetry of sleep science emerges when we recognize that the precise mechanisms of sleep and dreams, the slow waves of deep sleep, the rapid eye movements of REM sleep, the shifting balance of neurotransmitters, the reactivation and consolidation of memories are not merely technical details, but are the means through which your brain accomplishes something deeply meaningful. These mechanisms are the physical expression of a process that is simultaneously a biological necessity and a profound spiritual practice. Your nightly sleep is both a biochemical process and a ritual of renewal. Your dreams are both neural phenomena and visions of meaning. The equation that connects these two ways of understanding sleep and dreams is not a mathematical equation, but an existential one. The recognition that meaning and mechanism are not opposed, but are two ways of describing the same reality. Awakening with purpose, carrying the night into your day. As dawn approaches and your final REM period of the night comes to an end, your brain begins the transition back toward waking consciousness. Your body temperature starts to rise, your heart rate increases. Your brain waves begin to accelerate, shifting from the slow waves of deep sleep and the distinctive patterns of REM sleep toward the faster, more desynchronized patterns of waking consciousness. Your muscles begin to regain their tone, your sensory awareness begins to turn back toward the external world. The night is ending and a new day is beginning. Yet the work of the night, the restoration, the memory consolidation, the emotional processing, the healing, continues to influence you as you wake. The way you wake and the way you transition from sleep to waking consciousness can significantly influence the quality of your entire day. If you jolt awake suddenly to an alarm, if you immediately check your phone and plunge into the demands and stimulations of the day, you are abruptly severing the continuity between the night and the day. You are leaving behind the calm, the integration, the healing work of sleep. You are jumping directly into the stress and activation of waking life. While this might seem efficient, it actually disrupts the benefits of sleep and sets a tone of stress and fragmentation for the entire day. An alternative approach is to take time in the morning to maintain the continuity between the night and the day. When you first wake up, before you engage with the demands of the day, take a few moments to simply be present with yourself. Notice the quality of your mind in the moments after sleep. Notice any dreams you remember. Notice your body and how it feels. Notice your emotional state. This simple practice of presence and awareness can help you carry the benefits of sleep into your waking day. If you remember dreams from the night, taking a few moments to reflect on them can be valuable. You do not need to analyze them or interpret them in any formal way. Simply recall the dream and notice what emotions it evokes. Notice what images or themes stand out. This practice of paying attention to dreams helps you understand what your brain was working on during the night and can help you integrate the work of sleep more fully into your waking consciousness. Many people find it valuable to establish a morning practice that helps them transition gently from sleep to waking consciousness. This might be a period of meditation or mindfulness, a time of gentle stretching or yoga, a period of journaling, or simply time spent in quiet reflection before engaging with the day's demands. The specific practice matters less than the intention to maintain the continuity between night and day, to carry the calm and integration of sleep into waking consciousness. The benefits of sleep and the work of dreams do not end when you wake up. The memory consolidation that occurs during sleep continues to influence how you think and how you learn throughout the day. The emotional processing that occurs during dreams continues to influence your emotional regulation and your capacity to respond to challenges with resilience. The creative insights that emerge from dreams can continue to influence your problem-solving and your creative work. The healing that occurs during sleep can continue to support your physical and emotional well-being. Yet these benefits can be enhanced or diminished by how you approach your waking day. If you maintain a practice of conscious reflection and presence, if you continue to attend to your dreams and to the themes and concerns that emerge from them, if you approach your day with the kind of openness and acceptance that characterizes healthy sleep, you can deepen the benefits of sleep and extend them throughout your day. The modern world often treats sleep as something to be minimized, as an obstacle to productivity and engagement. Yet the science of sleep reveals that this is fundamentally misguided. Sleep is not an obstacle to productivity, but rather a prerequisite for it. You cannot think clearly without adequate sleep. You cannot learn effectively without adequate sleep. You cannot regulate your emotions without adequate sleep. You cannot maintain your health without adequate sleep. In a very real sense, sleep is the foundation upon which all of your waking accomplishments rest. The recognition of the importance of sleep should not lead to guilt or stress about sleep, but rather to a kind of reverence for sleep. Sleep is an opportunity to surrender to something larger than yourself, to trust in the intelligence of your body and your brain, to allow the deep work of restoration and healing to occur. When you approach sleep with this kind of reverence and trust, rather than with anxiety or resentment, sleep comes more easily and is more restorative. Similarly, the recognition of the significance of dreams should lead to a kind of respect for dreams. Your dreams are not trivial or meaningless, but are expressions of your brain's most sophisticated capacities. They are the means through which your brain works on the concerns and challenges that matter most to you. They are the means through which your brain transforms experience into wisdom. By paying attention to your dreams, by reflecting on them and engaging with them, you are honoring this work and deepening its benefits. As you move forward from this exploration of sleep and dreams, carrying the night into your day, Remember that the science and the poetry of sleep are not separate, but are two ways of understanding the same profound reality. Remember that your brain, even when you are asleep and dreaming, is engaged in work of tremendous intelligence and sophistication. Remember that sleep and dreams are not luxuries or indulgences, but are essential expressions of what it means to be human. Remember that by honoring your sleep and your dreams, by approaching them with presence and awareness, you are honoring the deepest dimensions of your own being. The mystery of dreams, the meeting point of science and poetry, of mechanism and meaning, of the physical and the spiritual, is not fully solved. There remain aspects of sleep and dreams that science has not yet explained. There remain dimensions of the dream experience that poetry struggles to capture. This remaining mystery is not a failure, but rather an invitation. It is an invitation to continue exploring, to continue questioning, to continue seeking to understand the remarkable phenomenon that occurs each night when you close your eyes and enter the realm of sleep. Thank you for joining me on this journey through the night. If this experience has brought you inner peace and expanded your understanding of sleep and dreams, I would appreciate a like and a subscription to Relaxing Science. We would also love to hear from you. Tell us where you are listening from and what insights or reflections this exploration has sparked for you. May your nights be restorative, may your dreams be meaningful, and may you carry the wisdom of the night into every day of your waking life. Sleep well, dream deeply, and awaken with purpose.